Hello, everyone, and welcome to the broadcast. We're going to be resuming our game dev project today. Did some more research. Hopefully, we're going to get the shader collision working. Again, signs as far as its viability are really good. We're just trying to figure out exact implementation. But before we do that, let's check in with the kitties. We do have Ember over on the shelf, all loafed. We have Mason snoozing in the bedroom. Sky is actually off to the right, below the camera on my right there. He is loafed for some reason there. That's not one of his usual spots. Unclear why. What's your problem, Sky? Hey. He's actively not looking at me. Sherbet passing through the play area, and you can just see Sammy's tail on the camera to my right there. So they're all accounted for. But let's see. Put the camera there. Switch over. Now, one of the things I found was a useful library linked off of Reddit, but it's on GitHub here. But somebody did a Boyd simulation, a sort of flocking algorithm using entirely shaders, and this gives us a basis, a springboard to use. For the purposes of getting our own code in place. It does demonstrate that we had our buffer set up in general correct here. Let's get the CS side of it. Script. This was also written for Godot, if I recall. Yeah. Some of our basics here. But one of the aspects, we can see all of our RIDs are stored. We need to do this. Primarily because we need to properly release them at the end. Of dealing with the shader. Any of these RIDs that we're not shutting down properly are going to cause a leak during our stream. Now, the way that we've set them up, it would not cause a leak until the game ended. Hey, that's great. But for the purposes of the stream and testing, we don't need a memory leak active. That will create a lot of red herrings during debugging. Sherbet has jumped onto the back of my chair, so I am off balance here a moment. He is getting increasingly comfortable with letting me scratch his back and whatnot, but it's under controlled circumstances. The cat tree next to the window, in the evenings he will come flying up that. He's a real agile climber. He will come flying up that for nightly back scratches. Anytime he's sleepy and I head into that room, he will sometimes leap up there so that he can get pets. He's purring away. But we need to make sure that we're releasing those. We're going to try a different model than what we were. So initially I had proposed a extra brute force pattern that would still be more than we want. So we have to deal with floats. We have to deal with 4-byte objects. There will be a number of 4-byte objects for every entity. Minimum. Floats or ints. It doesn't matter. They're the same size. Now we can do we need to have their positions. So that's a pair of floats. We'll handle it as just 2 arrays. It doesn't really matter either way. But they're X and Y. We need to know that they are active or not. Hello, buddy. Yes, I acknowledge you. I do. We can do that as a bool or an int. Again, it's largely irrelevant. Well, we can do it as a bool. We need to know that they're active or not so we can skip them. We need to know their type. Hello, yes. Is in the process of walking down me in order to get to one of the snoozing spots. He's likely going to take Ember's preferred spot. Brush here. I got a couple of swipes with it. Since he so infrequently comes within arm's reach, I don't get to brush him as much, so he's a bit sheddy right now. Beverage sip here. Yeah, he has usurped Ember's spot here. But right now we're shooting for 20,000 things. We can see in this example here they're using 10,000. So what we were proposing, so we had 2 for the position, 1 for the active state. We need another for the radius. So that's already effectively a vector 4 to account for the entities. I'm not going to make it a vector 4 because that creates assumptions we don't need. I could do the positions as vector 2s. That would be fine, and that keeps them coherent. I think it's vec2 in the shader. We'll have to check. Then we needed collision information, and that's where the wheels were coming off. Because the worst case scenario with collision detection is everything collides with everything else. And in order to capture that information under the old model, it would be a 20,000 by 19,999 array, which is big. If you're not aware, that's a lot. And since it would be 4 bytes per cell, that too is a big number. Let me do a little calculation here. Based on what I'm seeing, about 1.5 gigs, which we don't want to use. On top of it, we have a limit of, based on what I was able to find in documentation for compute shaders, 128 megs of buffer space. So no single buffer would be able to have that. And I don't want to create an arbitrary number of buffer RIDs to keep track of every entity just for the sake of having maximum in there. And that's setting aside taking up that 1.5 gigs of video RAM during the process. Or graphics card RAM, you know. So instead, what we're going to do is have a limited number of collisions per entity. Let's say 10, because that's going to be collisions calculated per physics frame, 30 to 60 times a second, depending on how we're feeling when we get to that point. So even if there are more than 10 collisions per object happening at that point, I feel like you're probably not going to notice, because most collisions that happen are going to get nullified if it's the same object. So if it's an object that is taking a hit and it takes 10 collisions at the same time, the 11th probably isn't going to matter any more than the 10th. Most likely it will either soak up all 10 and take a lot of damage, or iframes kick in and only the first one mattered. There are some edge cases to that. We can always increase this number. But it'll just be math. In any event, what we're going to do is we're going to have another array of integers to be the number of collisions in a given object. Each instance of the shader is going to be operating on a given object, so it will iterate over everything else, record each collision, and increment that number. It'll reset it to 0 each time, but it will record that number, and then it will populate identifiers for the available slots into another array that is x times the number of entities in size. So each entity will have a max collision number of indexes in that array sequentially. So, if it's 10, then the first 10 indexes in that array will be for entity 0, and so on. Entity 1 will be, if it was 10, it would be indexes 10 through 19. And the first one would be 0 through 9, kind of thing. And on and on and on. So we would cut calculation off as soon as all of them are filled, or once we've checked all entities for a given entity. Then on the outside, what we're going to do is iterate over the active and the collision count collections. And anytime we get active and a collision count greater than 0, we will then iterate over the collisions for that one up to max collisions, which would result in us generating as many as 10 in that case, as many as x collision objects to raise events with. That should keep it pretty trim. For the most part, the main cost is iterating over the collections for every entity. So we're going to iterate over the entity collection once in the aftermath of the collision check. So we should have a working algorithm here. Let's kind of box it out or lay it out in the code here. So one of the things we want to do is get buffer RIDs for all of these things. We want to keep them so that we can release them properly. We're going to do that for everything. For the most part, it seems like the rendering device is the thing that creates all of these, so we keep the rendering device around both to operate on, but also to ask to release the relevant RIDs that it has created. These RIDs. Adjust posture, try to make eyes function properly. See about getting a optometrist appointment in the near future. Run some checks on the old, optical sensors here. Welcome back, Sammy. I'm coding Sammy, so if you wanna be on my lap, you gotta sit. She's giving me a look like she disagrees with that assertion. Let's see here. Okay, so we have the buffer set up. We're going to... So the example is doing the brute force method for extracting information. That's getting the bytes and then just doing a block copy over top. And I may do that ultimately to avoid issues with it. Collision count buffer and collision data we can leverage the same way. For this purpose. So I'm going to have to go into the code and kind of parse what we were doing. One second, let me check. And we're back. Hey there, Laura. I had to go figure out which cat was crying because I heard them through an ear cup there. Guy was apparently upset about something. Isn't that right, bud? All right. Figure out what we were doing. This. Yeah, I know. Sure. Sure. Ah, you'd be a needy. All right, let's see here. Okay, so we are. For why we were doing bytes. Even set up the bytes. Oh man. Well, let's continue to set some stuff up. Don't think we need to create individual uniforms because these are RD uniform. We do need to keep anything that's an RID. So our uniform set needs to be initialized protected here. Circuits. Yeah, okay. Array and then uniform set. All right. Saved ourselves having to hunt down all the uniform sets as well. Ooh, all infantry, no vehicles in Zephon. I could still see that working. In our last game of Zephon, I only did cyber infantry. Those are at least only cyber infantry, and that they all came from the infantry building. The artillery guys come from the infantry building too. But no aircraft, no none of the actual like APCs or anything like that. This guy gets chin scratches. Especially if you're going with the human faction, you've got a lot of good tools for that with the the large infantry blocks with grenades and whatnot. You've got the field medics, you've got the rocket launchers. Lots of good kit there. Okay, pipeline is another one. Come on, camera one, behave. Might have to find a solution for camera one here. I mean, yeah, Tess, if you were going for all vehicles, no infantry, Cyber could get a little tricky because they just have that APC initially. Which, it's not a bad vehicle by any stretch. It's just you're not going to have a lot of them, and they're not like kill focused. For those that don't know, Zephon is a science fiction 4X game. Um, Kind of like Civ, but I believe Laura described it as what if, what if there was an alien invasion that deployed eldritch horrors at the same time that Skynet was waking up? So if uniform set, I need the compute pipeline as well. Set down to here. Yeah, but Zephon's been a lot of fun. It's got a lot going for it if you like 4X games. Hey there, Mud. Welcome. We are getting our brain wrapped around where we were with our compute shader code, and we're trying to transition over to the model that I've been researching since our last stream. Part of which is making sure that we keep any RIDs we create around so that we can properly release them. So I wasn't doing that, and that could lead to problems. Need to change the compute list. We'll need to change any instance of buffer to a fixed buffer. Probably making the buffer bytes elsewhere. Thinking. Sorry, I'm trying not to go silent while I'm doing this. So we're going back in. We're removing the use of the generic buffer. We need to use named buffers. Again, we need to create these RIDs, we need to remember them, and we need to get rid of them when we're actually done with them. We'll have to do it correctly, though, because we need to release it when the static object goes away, not when it leaves tree. No, I don't want radius data buffer. Data buffer. It keeps jumping in to make suggestions that the suggestion logic that is going clearly is going for a different solution. Is leading it towards an incorrect solution. Okay, we have the uniform and the uniform array. We can keep those generic. Shader file we don't need to keep around, or we don't seem to need to release that or the shader itself. Just gotta rub some dirt in it, walk it off, you're fine. Listen, we only have so many bandages. Okay, we got our compute list that we're creating. Now we're setting up that pipe. We're setting up the list of operations. These are being louder than usual. Collisions data. We are going to set it up so that there is a max collisions in here. We'll go with 10 for now. Dead Cells Catbot crossover. Nope. I wonder how big the sprites are in Dead Cells. I haven't implemented it yet because it's not an immediate priority, but I have been considering switching from 16 pixel squares to 32 pixel squares for the base sprite. That'll give me more range to make smaller things, like I could have projectiles that are noticeably smaller than the player without having to get really abstract. Because I know, based on quick count, the Vampire Survivor sprites for the characters are 32. So it's still doable while maintaining that kind of chunky pixel look. And for the most part, 16 by 16 is largely a original Game Boy era thing and more primitive stuff. Even, I mean, things like Dragon Quest sprites did, but I don't need to mimic that. Overworld sprites, I should say. Anyhow, so we have max collisions. We are setting up the data for collisions. Collisions count data will still be max entities. This will be max entities times. This is a shader collision manager dot max collisions. Yeah, we are referencing it directly, so Do we need the bytes, though? This does save us the song and dance of copying. Because we're always going to be dealing with bytes. So we can just store it directly into that array. Because this is one of the ones that updates on the regular. But we're going to have to do that for more of them in that scenario. Which means we should be storing that off if we're doing it that way. So we're not going to do it that way. Do it that way? I didn't think I had to do it that way. No, we were doing it that way. I think we do have to do it that way. All right. Let's look at some of these other ones real quick here. Sir, what's your problem? I know you think you want to walk that way, but you can't walk that way. They got into this habit of walking to the left, but there's a whole bunch of stuff in the way to the left now. So Sky is currently looking at me a bit resentfully that I turned him in a 180 so that he would walk off a way that he has room to walk off. The tan thing that Sherbet's back is up against, a little beige perhaps, is a soft stairway that climbs up to the bridge platform to the cat tree, which is one of the only reasons that they would go to the left, is to get to the cat tree. Okay. Let's count buffer bytes. This is actually collisions data buffer bytes. And we still do that. We still do that. All of them do that. But we're not going to have the bytes have their own buffer or anything like that. Okay. Should still be good there. List. Experimentation. Alright, so one of the big differences here, aside from some cleanup changes that we're making, is to this. For those that were not here earlier, what we're changing is that the collisions data output is going to be a single long array that has X indices for every entity in max entities. So all the other collections are max entities long. This one is max entities times max collisions. Max collisions is currently 10. So this will be 200,000 long. That is still way smaller than 400 million. Which will allow it to fit within our 128 meg limit. And give us a lot of room for increasing max entities. If we would want to. All right. Can't do any of that as far as the statics because that would be at creation. Don't know if we're going to get away with using a static destructor, though, but let's find out. Is this still the notation for it? I don't know if Tass is listening. Do you know off the top of your head what the syntax for a destructor is in C#? This is for a constructor. Well, that's unfortunate because it won't. Can't be exit tree. That's just for the object itself. Look up here. The tilde was there. Static. Nope. So what I'm trying to do is get the static data to be shut down. Because I can't have an individual instance being removed cause the static data to go away. That might mean we just need a shutdown logic in the core of it. That when the program ends, that it calls the cleanup for all of the relevant statics. It's unpleasant, but what you gonna do? Yeah, we'll need to have some sort of cleanup. Let's get that in there. do this? Oh, that'd call it there. And it's still okay if we call it on an instance, because that's what it's going to be, right? Let's find out. Static override. Yeah, okay. Tricky. Because these static members are... They can't get destroyed until the end. It would be kind of messy to remake them every time, because we're making gigantic arrays over and over. We're going to bloat the runtime memory of it. I wouldn't expect you to iterate over levels constantly, but let's not risk destabilization, you know? So how can we do this? Static can't call a member value. But there's not guaranteed to be an actual instance at the shutdown, because it will have been removed from the tree. So for those of you following along, we have static static variables in the class, because they are things that need to persist. We could... We can't really separate them, because these are very specific to the operation of a shader collision manager, though. Particular implementation can't override the static. Could we do it event-based? It's really roundabout. Okay, so let me tell you what I'm cooking here. So we could have in the parent class a static value that is entirely for I call cleanup on the parent class. So I call on collision manager cleanup. Then any of the others could listen for that event. Because as soon as they were invoked, they would be called, but... What would that do? I mean, static classes only get initialized when you invoke them, don't they? Like, you gotta reference the thing first. In some fashion. audio has been flaking out. I don't know why. This is a quandary. Let's think along here. So all of these are static because I don't want to recreate them every time we start. Every one of these is at least 20,000 entities long. Data buffer. Fix these later. To do that differently anyhow. So these are all static because we don't want to get rid of them each time. We don't want to constantly be removing and remaking these. At least that's the theory. There's nothing that stops us from doing that, though, and that would remove the question. Or remove the issue here. I had heard somebody reference the existence of a game called Gorilla Tag. Half pint. They seemed to enjoy it. I mean, that's what I would like it to be. Oh, okay. Okay, I see what you're getting at. Each of these could be an encapsulated thing that when they're destroyed, so when everything shuts down, they could do their proper release. Yeah. Definitely something to that. Yeah. Okay. We could wrap this within a class defined here. To contain these values. We can reference them in here. And when that goes away, the static object is finally released. we go through and we free this stuff. Yeah. Thinking while the ad break goes here. It just doesn't want me. Okay, so then I can move all of these. It's going to cause a bit of a... Actually getting naming conflicts when we do this. What is your actual problem, though? But why? Being helpful. None of those. Those are just suggestions. Why does it not like that? Protection level. Doesn't make sense. Ah, no, it does. Explicitly public. There. just move all of this inside that entity? I think I should. Okay, this part we can't. Right. So we're making this an internal class. It will be a static, but when it is destroyed, it will clean itself up. So it's doing all of the setup for its internal rendering device. And we can still manipulate it from the outside by having events that mess with all of its internal data here. So all of our update and our data retrieval logic will be put into that class. Yeah, that dodges the static issue. So all of that happens because of that. Dude. Okay. So now got questions or anything like that, feel free to fire them along. We're just doing a lot of thinking right now. Okay, let's look at our sample here and see what we've got to do. Okay, submit sync. Here. So we're going to have to do some tests where we change the data each time we run the shader to see that we get different results out of it each time, just to verify. So the local one is doing this. It's calling this on the static entity to run the shader each time. Longer term, we won't do this through physics process. We'll do it through a call that happens in a loop off of the physics process of the game. And we'll do that so that we can pause without relying fully on the in-game pause or the Godot pause. Maybe. We'll see. So run the shader there. We don't need to call load shader. You can just call that in there. We'll totally remember to do that. Okay, short term. All right, we're not generating errors, so this is a good start. So now we need to go into our shader file and account for the changes that we have made. Okay, so at the moment, we don't care about the exact stuff, and we're only using bindings 4 and 5 that count here. So do this. Let's get one of the others involved. Which one is the active buffer? Yes. Okay, active is binding 0. That makes sense. Uh, just going to start with I times 10. Buffer data I is 2. Nope, nope. It will be okay. So let's do this. So for each iteration on X that we go through, it'll have to see if there's a way to preload or to load this from the outside. To get how big this should be. Because if it has to be pre-compiled, then I have to make sure to update the shader anytime I update the constants. But let's brute force that. So it's going to iterate over, this shader is going to run 20,000 times. Since we're only sending one work group, I'm sorry, inside of this, it will iterate 20,000 times. So the global invocation ID X here should be accounting for the X, Y, and Z of work groups. So this X would be multiplied heavily if we had work groups going. But it should be 1 through 20,000. We're multiplying by 10 to get the base one. We would have interior inside of it to count collisions. But for now, we're just doubling the data here. So if we go in each time and we change what some of those values are, so we are just going to say I times 10. So we're going to print them out. During our going to set some data out here. We're going to initialize the so, One, and then in every physics process here. Take the same thing. Let's do this here. Okay, it's going to increase by I each time. So the 0, 1 will always be 0 and should always stay 0. The 1 should be, well, the 1 will increment by 1 each time, but every time it will also be doubled. So let's see if we're working correctly here. No overt errors. To the Godot manager. Yeah, I don't care. It complains about the shader each time because it doesn't handle it right. The Godot editor doesn't, I should say. A debugger is going to say there's a compile error. All right, let's step through that. Because of that. Okay. Yeah, I know. That an error. Sure. Okay, on 58. All right, so this is just, it's loading it. Okay, so we have a problem in the shader logic here. Let's simplify. And just say 1 for now. Okay. Then in the count data, Okay, we're doing a fixed one here for now because maybe I had something in the global the global count syntax going. Here to here, we click, we go back, we check our debugger, same issue. Oh. Spun a lot of wheels there. Here, still have errors. Still got problems. So we're not using this at the moment. Okay, we're still getting errors. Sure, it's not a comment syntax kind of thing. Yeah, I know I changed the code. Still errors, okay. So this is not the error service. It's this one here. General. Why did it not like that? Reading some documentation here. It is a bright white screen, so okay, there's a limit to the X, Y, and Z here. Okay, X and Y can only be as big as 1024. There's no shared memory between them. Nothing that they all work with at like in parallel kind of thing. Shouldn't be the limits of the uniforms. Okay, how are we gonna do? We need to compute this out so that we know how many times to iterate. We'll switch over to cameras while I read here. Give folks something to see. Looking at the Boyd's example here. See. Okay. Oh. Hey there, Copperpot. Yeah, we've got all 5 of them right now. I'm showing the camera while I'm reading some example code on GitHub and wiki documentation for shader language. This one is not eye burning. The wiki documentation for the shader language is eye burning, so we are minimizing that. At least minimizing your exposure to that, let's say. Let's do a computeless dispatch. Okay, so they're using the majority of it in work groups and having each one handle a small subset. I mean, in theory, I could subdivide it even further, but there's a risk there. So we're only going to use the x-axis here. And we're going to brute force that yet again. Okay, so instead of one worker, because we know it's like 65,000 something, based on the documentation, is the minimum value that is available for this. You then go into this one and say that it's only one. So it's going to become a really big number, a really, really big number. Oh, no. It'll be fine. This will always be plus. For the time being, we're only going to check the one. But this should actually resolve it. So this value, I'm sorry, in the collision buffer, each cell should be twice the corresponding count. So the first one will always be 0. The second one should be increasing by 2s. Third one should be, yeah, the first one is increasing by 2s, second one's increasing by 4s, that kind of thing. For the time being, though, the only one that should actually be changing is 1. Everything else should be 0. Okay, we have no errors. This is a start. So this is where I think I've got something that I need to do, and that's updating the data. So I change collision count data here. So I think we need to we need to update it within the rendering device. For that, we go into our logic here. So initializing stuff. Where is our clean up GPU? Something we're not doing, but we will do. Okay, we do the same thing again, essentially. We're going to do buffer update. The buffer's RID. Don't know what all the variables are, but we'll look at that in a moment. Okay, so we need the buffer, an offset, which is nothing, how big it is, and what the data is in bytes. We may end up needing to save the bytes in all of these again using memory marshalling, but for the time being, we'll do it the clunky way. With this. This is collision count buffer is an offset of 0. As array to array. So this is clunky. I don't want to constantly remarshal this. This is really just saying this is a representation of this as a span, and this is as an array, but I'm probably duplicating stuff I don't need to be duplicating. When we could just store that off. I don't know what's going to happen if I keep doing that. We aren't going to mess with this other one yet. It's still not working. Count buffer is changing each time. Are updating collisions buffer. Instance. Oh. That. Some weird thing here. Okay. Clearer. None of this is changing. Because we aren't updating. Okay. We're updating the count data, but not the collisions data. Some name consistency in here. Data, this is the buffer. And if we add bytes in, we'll be able to do that too. Collision count buffer is still fine. It's collisions buffer. Okay. Still not getting any result here. But collisions count data is being set correctly locally. But that might mean it's not making its way down. The fourth bit. Oh, because this is the first one. That's the 0. This is okay. Okay. And if we come around again, that's 2. Yeah. Okay. Okay, the data is correct there. Let's make sure we aren't missing something in the way that they are doing this update. Its length, and then we're passing in the bytes. Forget data. Responding buffer. This is the reason that I don't want to do this method, because it results in you having to make new arrays to account for what's coming in. We know that this works because it worked before. I just need to figure out how to make it work for what we're doing at this very moment. Data. Confusing. All right, let's do this for the other one too, just to be sure. Okay. Gonna give it another run, and then we're gonna take our periodic break here. Okay, so it's still not doing anything with the actual collisions data. Check real quickly. Yeah, they're just copying it over. So I think I have to store that bytes buffer over. We'll see. But we're going to take a quick break. And we're back. Okay. Let's preserve the bytes here. So we're going to have collision count. This is going to be a mapping between the two. So we are going to store this off when we create it initially. It's what we were doing early on in the process, and we stepped away from it. Now we're going back. Oh. Double equal. So bytes is equal to this array. So then run the shader. Instead of doing all of that again, bytes. Consistency. That. Now we run it over on the Godot side to get the immediate window here. And still nothing. I feel like if we're going to do that, that it's at least better this way. collisions data has nothing in it. Bytes and collision count bytes. Still nothing in collisions bytes at this point. Let's call this. Okay, it is returning nothing at all inside of this, so it's not doing what we want it to do. Let's just hard code this to 1 again. Okay, still nothing. Binding 5. Let's verify it's binding 5. You'd think that would cause an error if it wasn't binding 5, but hey, let's make sure. Oh, wait. we didn't go all the way through with this. Let's turn that dial there. Sure, we're doing that part. Count bytes, collisions bytes, still nothing. Okay, so we have we're never messing with the bytes. We know that this is functional when we do it this way. And we know it's not like stomping the value because it gets preserved through to here. Collisions data has nothing in it. Collisions bytes has nothing in it. Collision counts data has the second byte, second int set to 1, and then collisions count bytes. Bytes still has nothing. Hello, Gamma. Oh, we're missing Kitty Cat. Welcome. Update the buffer. What are we doing here? bytes. Do I have to marshal it each time? I was doing that. It didn't do a thing here. We marshaled it once already and created that. So let's do a quick test with a block copy. Source array, which is okay. Data, that, and then the number, which is the length of the bytes. Data, offset, offset, then thinking of this correctly. Should be right. For science and what have you. This shouldn't be necessary. Based on what we're understanding so far, but that might not be the case. All right. Test extra operations, go. Bytes has the fourth one in it now. Nothing in collisions bytes. Okay, so that didn't do anything adding the block copy, which is kind of good. It's not a huge operation, but it would be a needless operation. Let's check the shader on their side. Okay, let's... One... Block copies back, just in case. Bytes. Okay, it's incrementing. So that is, the bytes is properly updating. Collision's data is still not being impacted by what we're doing here. Took me a moment to parse that. The collisions count bytes is it's gotten big enough that the second byte has come into play in that integer. Okay, now let's go to the collisions bytes part. Collisions bytes. No change. Something is still going wrong. Is there a syntax thing I'm missing? Need edge here. Not for this. Something in the layouts that I'm missing. Are we missing here? Now, let's see. Our particle data buffer should be the one that we're messing with. Yeah. The dot data each time both integers. Is wrong with this. It's 4 and 5, right? Yeah, binding 4 and 5. This is still flowing how I want it to be. Run it for a little bit here. And we can stop it there. Count data is going up and collision count bytes is not. Okay, so we either need to marshal or we need to... Yeah, let's re-marshal it here. So we're gonna do this pattern more or less each time. Fundamentally should be the same thing. But let's ensure that it translates over. Okay, we run it for a bit. Then pause here. Okay, then we're going to look at our collisions data, which has nothing in it. Collisions bytes. Nothing. So the data should definitely be going in. words. Dough. Okay, so that value is still going. So what we're going to try real quick now is adjusting collision count 1. So that should be going up by 2. Okay, nothing that's being changed inside the shader. Like, this isn't doing anything. So the main isn't having any effect here. Which is odd. Submit and sync all at once. In a moment. To update it each time. As in, do we have to create a pipeline each time? I think we might have to. Okay. This is worth a check. Worth a check. Okay. So, previously, so this is us creating the uniform set. We shouldn't have to do that each time, I think. Yeah. Okay, so we create the pipeline in the compute list each time. Might be able to save the pipeline, shouldn't we? Okay, we've got the pipeline. I'm going to try not remaking the pipeline. close parens out of that. Okay. All right, so we've made it so that the setting up of the pipeline in the compute list, it's still not being updated. It still seems to be running fine, though. Hello, Sammy. Right, let's fully do it as they're doing it here. Once more. Nothing. Collisions, bites. Doesn't seem to have changed anything. So, put it back. Shader. Okay, so what we're doing here, we're trying to get data back out of the shader. So nothing we're doing in here seems to matter. Editing, like... So it seems like there's something with the retrieval that we're doing wrong. Because the bytes aren't even coming back different. Even the raw output of this is not coming back different. this? I mean, the only way we're going to know if it gets called is if we get a result. So I know that the data is changing going in. So the count bytes are going up. We are setting count data that is reflected in bytes. I think we actually need this. So if this was a dial that we turned that I don't think we need to turn. So if I go into here, so I'm coming in collisions count. We know we're trying. We know that if it didn't compile right, that we would get an error, but we don't know that the shader is actually being run. Okay, so the data is set. So if we don't marshal it, our bytes don't change. Our bytes don't change. It's not really a test, so. So let's go fully through the step here. So we have incremented, we have set the count data to have a 1 in the second value. Which would be, it would show up in 5 here. So we're going to marshal that into it. So we have our 1 in the second integer. This is our input value. So now we're marshaling the collisions count, or the collisions data, into it. We don't really need to do this part. But this is us passing it in. This is only really relevant as an output value. But you can have an input-output value shader. So now this is where we run the shader. It is, sadly, a void. So supposedly we run it, and then we sync it. Now, doing a sync right after is supposed to make it block until the GPU returns. So now we're going to extract the bytes into the count bytes from the count buffer. Now, this value should not have changed. It's collisions bytes, count bytes. So it's still the same. But collisions bytes should have been updated. Its 4 should be twice of the other one's 4. Because of this little bit right here. But it not that. But it not that at all. And if we go into our immediate here, and we see what was retrieved, same thing. We've got a nothing, so it's not just the just that. This right here is what triggers this part. And we are specifying that that we will use that shader. Let's jump through those hoops. So we get our shader file, and we get the shader's BRV here. This explodes if the shader doesn't compile. So it is getting the file, and it is valid code. Like, there's no compile error in it. We don't know that, I'm not sure that, it's not for sure that this actually has anything relevant here. But it does claim that it's valid. Nice. Is there a way? This will get us an RID back. Doing this again like they did in the code didn't seem to do anything. Let's just do it once, just to verify that I'm not messing something up elsewhere. This is okay, Tass. This is the world that we live in right now. Does not explode. Still nothing there. Okay, it's not invocation count. Some syntax thing that I'm missing? Let's try that. Is it going to be that silly? I mean, I'd kind of like if it was that silly. Nope. And the Godot documentation says that should be 450, so we'll leave it there. 430, right? Yeah. First uniform set. It's the number. It's the correct binding. Set position. we set the corresponding index in the data. So there's particle data. That's another thing. It's not buffer update there. That is a variable. It's a variable that I forgot that we weren't doing before. Count bytes is at 4. Collision count bytes got stomped. Collisions bytes did not change. Counts data, collisions count bytes. Yeah, collision count bytes got stomped there. Stop this again. To here. Submit in sync. Collisions count data has a 1 and collision count byte still has a 1. Okay, so I think we do need to do the update. Because then we don't have that kind of blowing back in our faces there. This implies that we don't need to keep that as a member variable since we redo it every time. I guess in theory that should still be fine. That two. Validate it together. Is that in again? Okay, so count data has a 1. Bytes has a 1. Now we're going to pull the data. Has a 1. Count bytes still has a 1. There we go. There we go. We got it. And then we need to marshal it back. Okay. Okay. Yeah. As memory marshal. Byte int. Cast it back. Here. Again, we won't need bytes because we can do all of that in line. But for now, go side, and we're gonna pause. Our output doesn't like something about that when we pause in the midst of it. Yep. It's real tiny, but the right number is twice the left number each time. Stop. Back into our shader, and instead of this one, we do this one. And here, say that this is actually 20,000. It's less than 10. Plus. This equals. Plus. Pipe. Yeah, it should still fit. And oh, right. Right. Running. Something not quite right here. Oh, data is going up by 1. Oh. This makes it the same across all of them. So we need to initialize this a little different here. Is equal to I. Click. Pause. Output. Lean in so I can read. Yes. Okay. Make this bigger. Apparently no. Okay. So, again, itty bitty text, but in sequence, each of these is 2 higher than the prior one. I'm sorry, the first number is 1 higher than the prior one in each row. The second number is 2 higher. So we have the full thing running. Here's what we had to do once I stop all of this. Okie dokie. So, missed elements. Let's actually pull you back up here a moment. I just want to test. I want to see if I can avoid remaking that resource ID there. See if we can just use the same pipeline. We can. Good. That's a resource identifier, so I don't want to remake it over and over. It's probably technically a leak in our example code there. Okay. So first thing is the compute list is something that we need to do each time. So we've moved that out of the initialization. Second, we need to recopy the data each time. So we are making a new byte array each time, which may... I mean, the RIDs we're still keeping clean, but... And we're copying over, so the same space might still work? Question mark? We'll see. We'll see. Wonder if we can do that as a cast each time here. We'll see. We'll see if there's optimization to do here. But we need to make sure that we are getting the data copied back and forth each time. We update the bytes data. And then on the other end, we update the actual data. I'll see if there's more nuance to this, but anywho. So that's what's been missing. That's what's been missing is we need to make sure that the data gets passed around. I've had some understanding errors about this memory marshal logic. I want to look it up further and make sure that we're doing something that is actually going to save us time here. Because if this is still ultimately just me copying the data back and forth, what are we winning here? Is this just a more efficient thing than block copy? I don't know. I should read up more on it. So then some more nuance. This number, the number of work groups, global work groups, can be as high as like 65,543 or something like that, before it becomes variable based on which implementation you're dealing with. On this side, the local side, this can be up to 1024, this can be up to 1024, and then I think this can be 60. A much smaller number. So when we put this to 20,000, it was causing errors. Now, what's actually happening in here? We should be getting numbers in all of them. So let's actually, I want to see. We're going to go to 11. And we are going to say, we initialize it. 11 is 42. Runs. Let's just go back over to here. Now, the last number should always be 42 and 84. But it's 0 and 0. Is that 0 and 0? Oh. 10. Do that again. 0 index, folks. 42 and 84. So this is relevant. I have set this value here. We're only incrementing the first 10 of them. This logic So I'm not going to set the 12th one. So we're going to bump this over to 12. And for that one, we should get 0 and 0. Yep, last one is 0 and 0. All right. So what's actually going on here is we're saying there are 20,000 work groups. We can tighten this up quite a bit. We can clean that up more. But what this should mean is that I can now start taking some of this data and, as parallel as possible, the GPU is going to go in and address each of them, because this global invocation ID X is going to be our... There's some fiddling with that I would have to do to change it, but this is essentially our index. Which of the 20,000 is this? We can greatly increase numbers this way if we play our cards right. So next time, we're going to start actually implementing this and start doing the collision checks, which means we'll be wiring it up so that it listens for entity creation, removal, movement, all of that goodness. And we will start doing the actual math in here, which will mean we're going to get the active state, and if it's active, we will proceed into getting its position and its radius, and we are going to go into every other entity, get its position and radius. Position, radius, and type. And corresponding type mask. So there's a lot of song and dance that we still need to do here. But we'll get all that together if it's active. And the two entities should be colliding. So the entity that we're looking at is looking for the type of the entity we've got. Hey there, Kevin. We just finished validating our compute shader logic. We've actually got it functional now. Well, the invocation of the compute shader and retrieval of data from is actually working. So our next goal will inevitably be to actually get it doing what we want it to do. So like right now, collision isn't happening. We just get a bunch of projectiles flying out. And the blobs don't react to them at all. But, they'll still time out. Our next step is to actually get the blobs reacting to the projectiles again. Our other method allows us to actually get them to collide, but in the numbers that we want to have happen, it is insufficient. So right now we have split into 9, and each of those will split into 9. So we're getting pretty big numbers here. So then 27 into 27, numbers rise substantially. We hit 10,000 and we're still holding pretty good, but this is without collision happening. When we put collision in, right about here is where it's going to start getting ugly. Let's have them do some fun stuff at that point. So with a more computationally complex movement type onto this, it's got our frames per second getting lower. We want collision to cost nothing if we can, and that's why we're moving it to the shader. We might have to see how much other logic we can do this with. Because if this works really well, I wonder how much we can make the GPU do for us. It's very busy, isn't it? The cat on the left, Kevin, is Sherbet. He is the brother of the cat on the right, Mason. Mason is my second largest cat, and Sherbet is my third largest. Let's see how many of them we can spot here. Might be able to see all 5. Depends on where Ember is. Yeah, we've got all 5. Ember is up in the tree, which is rare for her, but to some extent it's not too shocking because all of her other spots are occupied right now. She is the one with the orange ears up in the tree. She kind of blends in a little bit. Sammy is the tuxedo that's top center there. She is the second smallest. Ember is by far the smallest. She is kind of itty-bitty. Sky is the largest. He's the big fluffy gray and white one on the upper right. But yeah, those are my cats. Now this shows us that we do need to refine the movement to some extent, but if we cut this down, here is like, there's 15,000 things on screen. I'm sorry, 1,500. It's only when we cross into like the 10,000 cat territory that things start to slow down. But if the thing that we're working for with collision ends up costing nothing in here, we might be able to extend that logic into some of the movement as well, to get like an output vector. I don't know how far we can run that, but like here we can see the logic for moving in a spiral and moving in a spiral. Once that fades away here. So now we're just moving in straight lines. Actually, let's take that off the blobs too. So nothing is moving in a spiral now. The impact of moving in a straight line or moving towards the mouse like the blobs do is much less than just adding one spiral in there. Because now that we have close to 10,000 things spiraling, it's cost us 20 to 30 frames per second. That's not ideal. Now, to some extent, this is the cost of running the shader as frequently as we are. And it's doing largely nothing right now. So if we go into this here, and during the physics step, we just return. We're never going to run the shader. We're just doing a quick bit of science here before we finish wrapping up. Let's put a safety net in here. I do like cats, Kevin. I do like cats. Okay, so our shader's not free. It's actually a pretty non-trivial cost involved there. Let's run the shader. Let's see what our upward limit is with shader. Here, 1, 2, 3. We should hit about 10,000 with this. And last we saw it, it dropped us down to about 30 on the low end with this. Yeah. Okay, and if we hit this, this will put us into the 20K range. Okay, but still frames per second. This is actually really comparable, but it reaches a critical threshold sooner. Now, to be fair, we know it's weird that it's doing that we're getting that lurch. But that's kind of to be expected because we are hitting the limit, which means there are periods when we're not creating them when we otherwise would. It can't create more entities, more yarn balls, when we're sitting at 20,000, which means yarn balls that would be emitted during that period from the player are not being created. And every yarn ball created by the player actually turns into a whole lot of yarn balls. Every yarn ball emitted by the player is, let's see, 3 to the 7th yarn balls. So just removing one is a chunk that isn't showing up. So let's keep it at a more practical number here. Okay. So the question will be first, does the addition of actual collision logic in here matter much? And we can do a bit of a simulation on that, actually. So again, Kevin, what we're doing is we're making a game. We're doing some compute shader logic. We're doing some logic that runs on the graphics card instead of on your CPU. And this is new territory for me. I've never done this. Well, I've never made a game before. But in particular, I haven't done this type of coding since we started. And it's been a long time since I've done C, C++ style coding. So, you know, we're touching several bases here. So this will be for 0 I is less than 20,000 plus form a math operator plus I so that it can't flatten that. Okay, we are approximating sort of what we would be doing is for every individual entity, we're checking all of the other ones. Again, we're approximating it. We're not doing the actual operation, but this is of a similar complexity. And that is bad. That is real bad. So this is not doing what we need it to do at all. That is just crawling. It's noticeably worse than where we were before. So there is some operation we're doing here that is chewing up all of the benefit. Oh. We're not actually testing this properly because debug prints are expensive. But they shouldn't be that expensive. All right. Let's shear this down a little bit. So right now we're having it try to run 20,000 of them individually. But can we carve this down a little bit further? Because I doubt that it's going to actually be able to do this fully. So let's say 20,000, and then in this, we say 10. We say 2,000, and then we say 10. Oh, that made a huge difference. Okay, stress it. This will do 100. And there are 200 in parallel. This 1, 2, 3. We're using a Noida style weapon generation for this. That is, it's modular. Okay, still a pretty noticeable slowdown. It will ultimately depend because there's not really a big difference at this point. So now we're going to say 20. With 1,000 of them. Still sitting in about the same territory. What else can we do here? If we just say 10. Well, we would have to calculate this out to accomplish it. We're seeing where the performance falls here. Based on what we've seen, this is cheaper as far as calculation. We can spend a lot of time on the GPU doing stuff, but as soon as we've got all of these other objects moving around, it's still costing us a chunk of time. It's not... Okay, let's do the full science here. What we need to do is we go into Godot. We are going to find our startup resource here. So for our collision manager, we are going to use the prior one, the shape-based collision manager. So this does not use the shader. But it will cause actual collisions. Okay. This does prove it out, though. 30 frames per second at 10,000 is way better than we were. Okay, good. Not delusional. Well, entirely. Let's test that number further. Exactly, Taz. Well, we can't go that far, actually. One more test in here. Using the right one. It's the shader. I think that's kind of the threshold there. 1020 again. Again, we're doing shader-based checks here. Going to do a quick restart here. Because remember how I said I need to free RIDs? Haven't been doing that. I'm just reloading the project. Because it's a certainty that like we know that will leak memory over time. Again, shader based, doing 20,000 operations per physics frame. No actual collision processing, but they're slightly better, but it's still costing us a lot. Okay, so we have 10. We need 2,000. We have to figure out the sweet spot as far as shader work groups versus shader I'm sorry, global work groups versus local work groups. Like this is pretty good. Down to 5. So let's say what if we just do one worker at the moment? So we need to cover 20,000. Not really how I'd want to do it just now, but you know. That's not right. Interesting. Sure, 5 was working before. What are those errors? Might be about time to break for the night, given that we have stumbled upon something new and interesting. So it's failing to run. And I'm wondering if I have some sort of leaked process here. Checking. Yeah, I think I might have put myself into territory that will require that I reboot. Um, but we'll see. We'll see. In the meantime, well, we're going to stop for tonight. I'm going to have to look at it a little further and get prepped for the next stream. And still not sure when we're going to be doing our streams yet. Still trying to get a consistent schedule rolling once more, but hoping to hit each weekday. We'll see how that plays out, you know. But in the interim, I do hope you liked what you saw tonight, and if you did, remember to like, follow, subscribe, all that good stuff. Press the good buttons, it helps the channel. Oh. And I'm frazzled enough that I've completely dropped my my closing there. But I hope you had a good time, and I'll see you on the next broadcast. Good night, everyone.